this first one, we have to be able to convert between an exponential form and logarithmic form. The reason, we just said that they're inverses of each other. And the biggest thing that I'm going to ask you guys to put on the top of this sheet, every year I ask you to do this, and I will say it a million times. I want you to say the answer. Whoa, you got to spell it right. The answer to a log is an exponent. I will say this over and over and over, and this is one of the biggest things that will help you in this unit. Whenever you're solving a log, like the answer to it, the equals part, that answer is an exponent because they're exponential inverses. So here, this guy that makes these sheets talks about this rule of 7 or 7 rule. I don't know what he talks about. I don't use it, but it's there. Some people do like it. He's saying that this thing right here resembles a 7. If you handed that into me on a quiz, I'd be saying, what number is that? But he says it's a 7. I say to get through here, to convert this log base 2 of x equals y, to exponential form, start with this little saying we said up here, the answer to a log is always an exponent. That means this is an exponent. The answer to a log always will be an exponent. The other thing, if we're talking about exponential functions, a base always is a base. So this thing here, this 2, this is log base 2, how we read it. This is our base. So to write this, we'd say my base is 2 to the power of y should equal x. Done. The log's gone. We're converting it to exponential form. So we're saying 2 to the power of y is x. A base is a base. The answer is an exponent. And this thing here has no name. We've searched and searched for something that it should make sense. If we have a base and we have an exponent, we just call this, or I do anyways, that's the stuff. Some people call it the big number. I kind of get leery of calling that a big number because if something else is bigger than it in there, people's heads explode. The stuff. Okay, so let's look at the next guy. Oh boy, he sure tricked you. He wrote it the other way. A base is always a base. So what's the base in this question? 5? 5 to the power of 3, because the answer to a log is always an exponent, should equal the stuff, whatever the stuff is. Okay, well, we can't call it x because it's not always x. Okay, so thanks for coming out. But let's look at this guy. Convert 3 log b equals a to exponential form. Now, this guy's a little different than the ones above it. If I just look up here a little bit further, what's different with this as opposed to this? There's no base, number one, and there's another thing that's different as well. Yeah, there's a coefficient out front of 3, which is different. This guy had none. So what we have to do first is isolate that log statement. Now I have to tell you, just like back in trig, when you were doing like sine of 30 equals whatever, this is one number. It can never be separated. Like I can't divide sine out of there. It's the same thing with log. Log and whatever the stuff is behind it are stuck together representing one value. So I can't separate those. But I can easily move this 3. How do I get rid of it? Divide it out. So I'd say log b equals a over 3. Now we still have an issue that you guys brought up earlier. You said log b, the other difference is there's no base on this log. It's the same thing as saying, hey, there's no index on this radical. We just know that the index on this is? Oh no, 2. It's a square root. Okay, same thing if I said y to the power. There's no power here, but what's its power? 1. There's certain things in math that we use so commonly that we don't actually have to write it. This is one of these. When there is no log or base on the log, it's a base 10. Okay, log base 10 of a over 3. Now we should have no problem either doing that guy's 7 rule or just doing what we said. A base always remains a base. So what would we have as a base? 10. The answer to a log is an exponent. So to the a over 3 equals b, the stuff. Now, Cole, what was your question? We said, Cole's question is, where did the 10 come from? From here to here. If there is no base indicated, we just know it's a base 10. Okay? And we said, just like if in the square root, if there's no index, we know that index is 2. We just don't write it. Okay? Is there another way I can write this? This is a great answer, by the way. This is exponential form. That's what it's looking for. You guys should know, and we did review exponents, you guys should know that if I have an exponent that's a fraction, what does that tell you about that whole term, that whole base in the exponent? Well, it's not flipped. That's a negative exponent. It's a radical. This thing here also could have been the cubed root of 10 to the power of a equals b. Now that's not exponential form. It's a radical form, but you have to be able to flip between those because those will come up here soon. All right, this last guy, it says solve for x. So a little different. It's just not saying convert. It's actually saying solve it. Here, there's no way I can isolate this 2x from log base 3 because we said we can't separate those two. That's one term. But I could write it in the other form. What is this log base 3 of 2x equals y in exponential form? 3 to the power of y equals 2x. Now it says solve for x. So this is exponential form. How do I solve for x? Divide the 2 out, and we just have x equals 2 to the power of y over 2. I cannot say, because I just heard someone kind of mumble this. They said, well, it's like 3/2 to the power of y. Why is this not true?
It's only on the 3.
It's only on the 3. It had nothing to do with the denominator. So this thing here is no good. It's only on the 3. Okay, so there's what, 6 little questions here? Give it a shot. All right, let's go the other way, converting exponential to log. Now, dude said 7. I don't know what he'd say this time. Backwards 7. But if we just remember the answer to an exponent, or sorry, the answer to a log is an exponent, and a base is always a base, we should be laughing here, because look, convert this to logarithmic form. Obviously, I need the word log in there. Okay, log base what? What's the base in this? X. Log base x, y equals 2. Okay, the answer to a log is an exponent, so it goes out the back. The base is a base. The stuff just turns into be the stuff. Convert, oh no, this to logarithmic form. A equals 10 times x to the power of 4. In this, we should be looking at, oh, my power isn't isolated. So just like I needed to isolate the log, I better isolate the power here. So what is the power?
What number is that?
It's a 4, I think. X to the 4th. Now, this is a lot different than writing it this way. And teaching math from grade 10, 11, 12, a lot of you still don't know the difference between this and this. Okay? Right here, the 4 is only on the x. Here it's on both. So they'd be 2 different logarithmic forms. But we need to isolate that x to the 4th, so we divide out the 10. So a over 10 equals x to the 4. Now, we could even start in an easier place. The answer to a log has to be an exponent. So what's my answer going to be? 4. What's my base going to be? X. So that should be subscript. Okay? Log base x of a over 10 is 4. And it just says convert it. We've done it. Okay? Be careful here. I will mark things wrong like this. Log x. I know you know what you're talking about, but you have to write it properly. If it's supposed to be a subscript, make it small, make it below. Don't also be, I taught this whole unit, the year of the fire. I won't forget. The year of the fire, taught this unit. Then we had to go to the junior high to teach if you had a 30 level class, because we couldn't miss 2 weeks of math 30. So I'm teaching over there. We're doing logs, reviewing it for the test, and someone puts their hands up and says, whoa, 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 whoa. What's this 10G you keep writing? I'm like, oh, test is tomorrow. I don't know what it is. We're talking, it was pure 30 at the time. What's this 10G? I'm like, oh my gosh. That says log. We've been doing it for 2 weeks now. Anyways, let's look at this. Convert the root of y equals 3x to logarithmic form. Problem here, we don't have a power, but we sort of have a power if you know enough. It's y to the 1/2. This thing here is y to the half. That's why we were reviewing that earlier. Equals 3x. Is my power isolated? Sure it is. So what is my logarithmic form going to be? Log of what? Log of y, because a base is a base, of 3x equals a half. Log form. No big deal. Okay. Convert this guy, 10 to the power of x minus y over a, or equals a over b, to log form. Give it a shot. All right, let's look at this guy. What's my base of my log going to be in example 4? 10. So log base 10. What's going to be the stuff behind it? A over b equals x minus y, and we're done. That's it. If it said solve for y, you'd have to move stuff around. Solve for x, move stuff. All it says is right in log form, I did. This guy here. Oh, yeah. Eric's saying, could we do this? Is this the same thing? It's great. This is actually a better answer, but on diploma exams, for some reason, they're, and I'm not going to say they always will, but they're including the base 10. So if it's there, yay, you won't forget that a base 10 when it's not written. If it's not there, you should just know it is a base 10. All right, someone said this guy is where the wheels fall off. Math gets impossible. It says write this in exponential form. I could simplify this from grade 9. If I'm dividing two powers with the same bases, what do I do to their exponents? What do I do? Subtract them. So this is b to the power of m minus n. Now we're almost to the identical question above it. We just have to say, okay, log, a base is always a base, so a b. The stuff, the answer is always an exponent. We're done. So if you like this guy's rule of 7, use it. There's nothing wrong with that. I will always refer to just look at your exponent. That becomes your answer. A base is a base. Fill in the rest. Include the word 10g or log. Okay. 6 questions there to do a little bit of work. Give it a shot, and then we'll call it a day.